This question is about the dynamic range of a quantizer. They're asking for a definition and to show how it's related to n. Specifically, we need to show that it's approximately equal to 6 times n. That's the dynamic range in decibels. Now, the dynamic range is actually a ratio. It's a ratio of two amplitudes. The largest amplitude that will avoid clipping and the smallest amplitude whose variations will be undetected by the quantizer. So if you imagine a quantizer with these levels here, a peak-to-peak signal of 2 times Vmax, that's the largest signal that won't be clipped. So anything larger than that will be clipped. Anything larger than 2 times this voltage Vmax will be clipped. And the minimum signal whose variations would go undetected, we're calling Vmin. So your peak to peak would be twice Vmin. So anything smaller than that wouldn't be detected. So the ratio of these two, that's your dynamic range. So it's Vmax over Vmin. Okay, what I've drawn here is twice Vmax and twice Vmin, so I've included the 2's. But it's Vmax over Vmin. Now, if you remember that the number of levels of a quantizer is linked to the number of bits, and the step size of a quantizer, that is basically what we're saying. We're saying twice Vmin is equal to step size delta. So that's what we've done here. That twice the minimum voltage is our step size. And we can relate step size to number of bits because the number of levels is 2 to the power n. So if you divide the peak-to-peak voltage divided by 2 to the power n, that will give you your step size. So if you substitute that, you end up with your dynamic range simply being 2 to the power n. So that is your dynamic range, but not in decibels. To convert to decibels, we take the logarithm of that, or 20 times the logarithm of that. So 20 times log base 10 of 2 to the n. If you multiply 20 by n, you end up with 20n log 2, and 20 multiplied by log 2 to the base 10 will give you 6.02, which is close enough to 6. So that's your dynamic range in decibels.